Alright, this is topic 28, tangent lines of trig functions. So we're continuing on with the derivatives of trig functions. We're just going to use them to find the equation of a line. So notice in example 1, it says write the equation of the tangent and normal line. Alright, to the curve y is equal to cotangent x minus 2 cosecant x at the point x is equal to pi over 3. Okay, so don't forget that I've talked about this in class, but remember that the normal line is perpendicular to the tangent line. Don't forget that, right? So the normal line is perpendicular to the tangent line, which means the slope would be its negative reciprocal. All right, and we will use the same x and the same y coordinate. So anyway, so we're gonna write the equation of a line, and remember that we always need a point and a slope. Okay, so on this one, the first thing I'm gonna do is I'm gonna find the y coordinate of the tangent line. So I'm going to plug in pi over 3 into this equation right here. All right, so we have the cotangent of pi over 3 minus 2 cosecant of pi over 3. All right, well, we don't have a calculator, so I guess we're going to have to do this the hard way. Now, this brings me to my next point. Remember your trig. Alright, I may have another quiz here pretty soon, because this is going to become more and more important for you to remember this. So I know I haven't had one in a while, but it's coming. Right, so remember the cotangent is like the same thing as 1 over tangent. So this would be the same thing as cosine over sine, or adjacent. Let's see, pi over 3 cotangent, so I gotta write my SOHCAHTOA here. Alright, so that would be adjacent over opposite. Adjacent over opposite. Alright, so the cotangent of pi over 3 would be 1 over square roots of 3. But if I simplify that, I would get square root of 3 over 3. Alright, and on the next one I would have minus 2, and the cosecant of pi over 3, remember the cosecant is the same as the opposite of sine, is 1 over sine basically. So sine is normally opposite over hypotenuse, so it should be opposite over hypotenuse, but now I'm going to have hypotenuse over opposite. So I have 2 over the square roots of 3, and if I simplify that, I would get, let's see, I would have 2 square roots of 3 over 3. Yeah, that's what I would have. Okay, so let's make sure we understand one another. This right here, let me see if I can find another color so I can write it so you understand what I'm doing here. Without a calculator. And again, if you remember this from trig, you're fine. You know, just use whatever way you feel more comfortable with. Remember that sine is the opposite of this, so it would be hypotenuse over opposite. Hypotenuse is this, opposite would be this, but because I want to rationalize the denominator, I multiply top and bottom by the square roots of 3, which then gives me that. Okay, and I did the same kind of thing on the cotangent part. Alright, so now this is going to be square roots of 3 over 3. This is going to be minus 4 square roots of 3 over 3. So that's going to give me negative square roots of 3 over 3. Alright, which is just negative square roots of 3. Alright, so this right here is the y coordinate. So I just now found my y coordinate. So I'm going to now try to figure out the slope, or I'm going to try to figure out the slope at x is equal to pi over 3, but the first thing I need to do is I need to find the derivative, right? So because I find the derivative, and if I plug that in, I would get my slope. So the derivative of this, alright, now hopefully if you still don't remember, which is fine, that was just happened one lesson ago, you still have them here in your notes from last time, or on 27. So the derivative of cotangent is negative cosecant square. Right, so we have negative cosecant square x plus the derivative of cosecant is cosecant cotangent, negative cosecant cotangent. Oh, wait a minute. Oh, yeah, I already made it negative, and negative makes it a positive. Okay. I was wondering how I got that. Should have never questioned myself here. All right, so that's what I have. Remember, that's a negative, but because I have a negative here originally, that became a positive, okay? So that's the derivative. And then now, I'm going to plug in pi over 3 into these, all right? So I have alright, so now just to rewrite that. Now I already wrote this ahead of time, but this will be the same thing, the cosecant of pi over 3. So figure out what the cosecant of pi over 3 is, alright, which is what I figure out here, okay? So then I would have a negative 2 square roots of 3 over 3. But because this is cosecant square, all I have to do is just square this. Alright, so again, it's the same thing as the cosecant, but with a square on it, because this is cosecant square. So plus 2 of the same thing, you have 2 square roots of 3 over 3. And the cotangent, which is what I have over here, is square roots of 3 over 3. Alright, as I simplify all of this, notice that would give me a negative 4 times a 3 over 9. Remember, I'm squaring all of these. I square that, and that. Okay, now I can obviously simplify this here in a little while. And then now this right here, let's see what I got. Square roots of 3 times that. Okay. Let me see what happens here. I would have a 4 here. It would be 4 times 3 over 9 also. How weird. Let's see, did I do that right? No, I did not. No, yeah, I did. Okay, so that's good. That's right. Notice that right here I have a 2 times 2, which gave me that 4 right here that you see here. The square root of 3 times the square root of 3 is 3. And then you got 3 times 3, which is 9. Alright, so at that point, therefore, I'm going to rewrite that one more time. I think you can already tell this is going to be 0. This will be negative 12 over 9 plus 12 over 9. Alright, so the slope at pi over 3 is 0. Okay, so the equation of the tangent line. So here's the equation of the tangent line at x is equal to pi over 3 would be equal to y plus square roots of 3, right? That's my y coordinate, remember, so I have a minus y1. y1 happened to be negative, so that's positive now. It's equal to the slope times x pi over 3. But notice that because of that 0, that's going to make the whole thing 0, so the equation of the tangent line would be y is equal to negative pi over 3. Okay? Now, on the next part, I need to figure out the equation of the normal. And remember that the slope would be the negative reciprocal of this, which is kind of weird because this is 0. But if you were to flip this, right, this is a horizontal line. So the equation of the normal line is a perpendicular line. So since it's the equation of it's the perpendicular line, let me just draw you a picture. I think it would be better if I do. All right, so let's say that I have this equation right here. Let me think. Okay, let's say that y is equal to the square root of 3, which would be around 1 point something something, happens around here. All right, and that point that I had found earlier, if you remember, was let's call this pi over 3, comma, negative square roots of 3. That's the x and y coordinate of the point that I was looking for earlier, right? So now, remember, this is my x-axis, this is my y-axis, okay, just to make sure we're clear on that. And this pink line is the equation of the tangent line that I just found. So this right here is y is equal to negative square roots of 3. Right, so the equation of the normal line, therefore, if I want a normal line, it has to be perpendicular. It would go right through that point. So the equation of this line right here is just x is equal to pi over 3. All right, so this right here would just have to be x is equal to pi over 3. Okay, so I hope that picture helps about why that has to be like that. Remember, a vertical line like this would have to be crossing that goes through this point as only the x coordinate. This kind of goes back to the stuff that you learn in Algebra 2 / pre-cal, but that would be the answer. All right, so, and as far as the bottom, it says review. I'm not going to review for you, but I promise you it will be on the test. Okay, so make sure to review this, look it back in your notes, or even Google it if you want to. Well, you shouldn't have to Google this one and this one, okay? So figure that out on your own. I'm not going to fill that out. If you got any questions, let me know. Again, this is the last lesson before your test.